Nice to be here. Nice to talk to all you guys. I'm working at ownCloud since, I don't know, employee number 7, and so I work on a lot of the core stuff, and I'm here to show you some of the ideas that we're following up on regarding, well, how to scale ownCloud beyond what's currently possible with the file cache as it is today. So I have to apologize, these slides were made in LibreOffice. I tried to export them as PDF, that crashed, so I just tried to export them as PowerPoint, and this is what that looked like. So there's still stuff to do for these guys. The motivation is that there are customers talking to us saying, oh, you know, this file cache, there are so many updates on it, it doesn't really scale. And the theory is, well, probably that's because the implementation is a little bit naive, and actually the problem is that we have to propagate an e-tag up the file hierarchy tree, because that's what the WebDAV protocol requires us to do. So what could we probably do to solve that? One idea is obviously, well, just get rid of it, do something else, or sharding it or splitting it up. That's something that we saw at what Nextcloud is doing. So we are looking into that as well. And these are just the theories that we want to try and either prove right or prove wrong. So we don't have a solution ready. We're working on proof of concepts to see if which of these approaches might succeed. So the first one, we're calling it raw storage, is basically the idea to use the file system itself to store metadata like the e-tag in extended attributes. The challenge here is that ownCloud itself relies on the file ID. For example, shares, tags, and comments are all tied to the file ID in the file cache table. That means whatever ID we use from the file system must be really, really, really unique. We see some challenges in the next slide, but currently we are now maintaining two things. Two things in the world think that they know everything about the data: the file system, as well as the database. So if we can get rid of the file system information if we can get rid of the file cache in the ownCloud database, we will only have basically one master, and then that should solve hopefully some of the problems regarding scanning, because if people have to scan the file system to pick up files, that's still a broken concept. So we basically just want to get rid of that. The next problem is file systems themselves don't propagate e-tags. What is an e-tag? An e-tag basically tells our sync clients this file has changed since the last time you visited. So whenever the sync client wants to do a sync, it tells us, hey, do you have anything, or this is the last e-tag that I have from you, have you changed? And if the server can say, okay, yeah, sure, there's a new e-tag, the sync client will start synchronizing, looking into all the subdirectories, and pulling out new information and downloading new stuff. We are currently propagating this e-tag, so when you upload a file, we will create an e-tag for it, and also propagate that e-tag up the directory tree to your root folder. That is how the sync client is able to pick up changes. But that is a requirement of WebDAV, and the file systems themselves don't do that. So we somehow have to either use a different mechanism. Basically, we still update the e-tag ourselves, or probably there is a file system that has mechanisms, policies that allow us to do that outside of ownCloud. As it turns out, we started with a standard approach of using a POSIX file system. We are using the inode as the file ID, which is okay, as it is unique over a single file system. And we are storing the e-tag as an extended attribute. We still propagate the e-tag ourselves, but the limitations there is for testing this approach, that might be okay, but beware, inodes are reused by file systems. So it might happen that if you upload a file, share it, delete it, and then upload a different file, that one has the same file ID. So this is only for proof of concept and testing if it's, at least from a performance perspective, a feasible approach to use the file system as a replacement for the database. There are some technical limitations. It requires additional PHP modules, but yeah, that's okay. For now, since we're not taking into account the device ID of a file, you cannot really use multiple file systems. You cannot mount 2 or 3 storages because the inodes might collide. So, and then all hell breaks loose. So for testing purposes, this is still okay. It's actually working pretty fine. We had to implement a caching mechanism that allows us to quickly look up a path or a file by its ID, because that's what we currently do with a database. Most of the requests have the file ID, and we just tell it, hey, please give me the file for this ID, which is a very quick lookup in modern databases. For file systems, that's a very expensive operation, because you would have to scan through all the files and ask each file, what is your ID? What is your ID? There is no quick way of doing that. So we had to cache that. But that's working fine, and it's okay. And IBM is actually testing the performance of this. I would have recommended you to Olaf, who was sitting there this morning, but he had to leave. But he'll be here tomorrow, so try to talk to Olaf or to Felix. He can direct you to Olaf because he knows him. Olaf has been testing this approach and this application, and is actually the guy on the IBM side responsible for GPFS and IBM Spectrum Scale. They're trying to use either the policy engine or lightweight events to propagate the e-tags in the file tree, which would allow them to transparently handle updates. When somebody updates a file outside of ownCloud, it would get picked up by ownCloud, and the sync clients would synchronize, which is a slightly different use case than what we are trying to prove or trying to falsify, the theory that using the file cache scales better than the database. But, well, that's IBM. Let them try this. It's all cool because we can use their lab, and they have tons of machines and tons of clients, and it's pretty nice. So let them toy with it, and we're there to help them. The second idea is similar to what the Nextcloud guys presented regarding sharding, or basically clustering or tying multiple federated instances together. Because, as Frank Karliczek already announced, there might still be cases where a single database is not enough because of too many users, too many files, too many activities going on, too much stuff to store into a single table. And then the question is, of course, horizontal versus vertical scaling. However, federation is not seamless. You would expose the different URLs for each instance if you were to use it as it is today. That's not something that you might have. The Skibo guys are doing it that way, and it scales quite nice. But actually, you want to hide the whole zoo of instances behind a single URL. There is, of course, another nice, or something that you also want to. When we are seeing updates between ownCloud instances or an ownCloud update, we would actually like to support user-by-user migration, or at least groups of users that can test drive the new version, so that you can have early adopters, where you can see how will the new version behave, are there problems, how do we roll back. But for that to work, you still need to somehow hide the complexity and the switching of which service to use behind a load balancer, basically. We started with HA proxy. Basically, I have to give all kudos to the guys from Switch, because they came up with the idea. So, hey, we have this HA proxy, and we're using cookies to basically direct the user to a different instance of ownCloud. Can't you help us polish this a little bit? And that works quite well. We started out with this. They initially made the HI proxy set the cookie. We now changed that a little bit, but the instances themselves are independent. So it's a federated. Each instance is a dedicated ownCloud instance, and they share stuff via federated sharing. Okay, so what we did is we actually implemented, or I implemented an application that can take in any login information. So if you come out at node A, and I get your username and password, you get, I will find the right node internally. You can implement a lookup service there, which is what Nextcloud does, or you hard-code it, which is what Switch currently has. They know that for this email domain, this node is responsible, and for this email domain, that one is responsible. So they split it via the domain. And then we can automatically log in the user at that instance, return the right cookie, as well as the new ownCloud session, and the client is able to log in. And that works pretty well, but that's just the easy part. The harder part is sharing, federated sharing. You've seen that Nextcloud guys were doing group shares, and that's in our case, that's not even necessary because there are no group shares. So we're going to work on a small solution first, where we are going to just add the capability to federated sharing to work in a clustered environment without exposing the individual ownCloud instance URLs to the outside world. So we will completely hide any URLs that are inside your cluster, and all users will see from the outside is just one URL. Of course, there are some challenges, yes. If you have multiple instances and they generate link shares, you have to take into account that, well, the tokens that you generate for public links must be unique over all instances. Well, that's fairly easy to do. There might be some changes required to the ownCloud core, which is okay. The current proof of concept, I literally worked on this last Friday, but I didn't have the time to get any further on it. So that's what we do there. Of course, what do we need to do? We need to do the math. I'm happy that Piotr is with us because he knows all the math stuff and all the statistic stuff, and he's happy doing calculations. So I hope that either he or the guy from IBM will provide us some raw numbers. The IBM guys do have the hardware that we need to really compare which solution scales better. If this solution, I think they might even be combined. So they don't exclude each other, but it might actually make sense to use a raw storage access on all nodes, because when you then migrate users, you don't have to migrate any data on the storage because it's already there. So if you have any ideas or any use cases that you see regarding clustering, sharing, sharding, however you want to call it, just go to Central or send us or go to GitHub to help us, or talk to Felix and Olaf, because they know what we're currently working on. Any questions?
Any applause? Don't be so modest. Room for 2 questions. There's one.
If you are thinking about the inode file ID, you don't think about moving all the data to a different file system, for example, when you're changing hardware or something like that, because it means that every file gets changed its file ID, because the inode from the new file system will be definitely different.
Yes, definitely. And so there are 2 things. Yes, we either need to take into account, if we want to make this into a product, we either need to take into account the device ID as well to uniquely, that's one part. We need to uniquely identify all the files on all storages. That means including the device ID. The other part is, do we want to still store metadata information in the database, or do we just want to store, for example, the sharing information as ACLs and tags as another attribute? Do we want to store comments by tagging file or by adding a UUID as an extended attribute, which we can then look up in the database, so that we are not always relying on that thing, on the file ID. For the purpose of testing if the file system itself can scale better than a database, I think it's okay to say, okay, we're just going to take the inode to have something unique. I totally agree. It's not unique, and we need to be very aware. The biggest problem is inodes, file systems reuse inodes. So if you delete something and create something new, you might get the same inode. That's the bigger problem. Okay. Any other questions?
I'm the chair.
Sorry.
Would you like to tell that person that he can ask you a question?
Yes, please. Yes, I need to run for a train at 16:49.
See if we can make him miss it. Drag out that question.
Yes, I can give you my card on the way out. No,
He's about to come down. That's the funny thing. That's the next speaker.
Okay, cool.